Why this vision impairment simulator takes so many resources. Too many resources. I can hear my CPU going full on. Can actually test it for a sec. Yeah, it's the Chrome, so it's in the Chrome browser. Looks like it's not doing much, but then yes, the stream takes quite a bit. So I don't know why must be the GPU. So we're not actually monitoring for GPU, are we? Yeah, we're using like 41% of the video engine and stuff, but it's probably split between the live stream and this tool and other things as well. Just stop a few things, see what difference does it make. So we have an excellent connection. So we are live, if anyone. Anyone wants to join in. Oh, let me copy paste properly. Copy pasting is hard, isn't it? Copy pasting is a skill. We shared a bunch of things. Okay, close it. Okay, I get it. No, wait, let's actually test it. So if we hide it, yeah, so that yeah, now the GPU went down. Or was it CPU? Should have been GPU enabled process, but not entirely sure. Not entirely sure. All I know is my fans went quiet, and that's turning it back again. Yeah, now they start throttling. So I don't know what's up with that. How about that the Ava tool? Yeah, the eye tracker. Is that any better? Tracker. Yeah, it's still using some resources, but much less. So I'm not sure if it's CPU or GPU. Yeah, that's something we have to test out. Let's see, I'll turn our light on. Yeah, this one's too bright in my eyes. It should make the Eye tracking more better? No. To change the threshold. I don't know if let me know if it's working okay or not. But yeah, this tool is just using less resources. Using less. Using less resources. Yeah, so we have a bunch of stuff going on. And the seizure detection project, so you can go check it out. It's essentially the results of processing training on this dataset. It's about, from memory, 600 spectrogram images like this. So you can actually, maybe when it's waking up, scroll through the images. Yeah, it should be easy to scroll for this one because there's less in the training and validation set. Most of them are in the training set, so there are much more images there. You just go scroll through them. In theory, yeah, something wrong there. It's okay. Yeah, validation seemed to be higher quality, like more confident seizures. So that's what the spectrogram doing during seizure. And then we have training. It was the last time we trained, we got to test accuracy of 90%, but the one before last we got to 96.6%. We only had 2 false negatives. So when the algorithm actually indicated a no seizure, whereas the actual data, what's called the baseline, the true, it's called, get the name, something truth, ground truth. Yeah, ground truth was seizure. So it did 2 essentially false it's false positive, false negatives. They are false negatives because it's negatively said it's a non-seizure, where it's actually is seizure, but it had 0 false positives. So no indication of seizure when so all the non-seizures were indicated. All the seizures were indicated as. Again, I'm confused. Wait, confusion matrix. That's why it's called confusion matrix, isn't it? To get you confused, but no, I'm just joking. So all the non-seizures were labeled as non-seizures. And some of the seizures were labeled as non-seizures. So those would be, false negatives. So eventually test accuracy of 96%, average training accuracy. Yeah, so you can see it from the these plots as well. Model accuracy, so getting up to almost 100% both for training and validation, and getting to almost 0.1 on the loss function, both for training and validation. Didn't quite saturate there, so we probably could have run for more epoch, but we already did like 70, so it should be enough. And yeah, we're showing the misclassified images. These are these 2, and you can select the run number. So then we run again, and we had a slightly poorer performance with instead of the 2 false negatives, we had 6. but still 0 false positives. And those are the examples. So this is essentially, you can see where it's going wrong. So in this case, the true label is 1, meaning seizure, but the prediction is non-seizure. And same for all of those. Yet probably this one and that one are oddly misclassified. You can kind of see the seizure frequency in there, like slowing down, so on and so forth. You can see a better version here. This probably be a more representative spectrogram of a seizing EEG channel. So go check out this tool. It's all on BioniChaos.com. You can find the link pretty much everywhere. Let's go back to 100%. Yeah, still testing our eyes, so they will highly depend on the light in the room. But test this tool as well. Let me know how you go with it. And we'll start developing in a second. Yeah, perhaps we should go over other tools, unless there's any specific questions or you want me to cover anything in particular. Actually, ChatGPT is pretty good at asking questions, so we might as well use that. And because it's a robot, it actually needs XML, probably be better for it. Be any better. So we are live streaming at the moment. If you have any specific interests, do let me know. This is currently what we have on the site, all the tools with a description. Some of them are not working. Maybe we can just go over this list of tools and we either randomly or somehow, whichever way, select one that we will be working on, or potentially doing a totally new one. There's actually a list of potential things we might be working on. Yeah, around the detection theory, EEG signal generation. We already have something, but from memory we have to keep improving it. EEG software. Yeah, we want to focus on our own, so we won't be covering any other software, just not yet, unless there's something super interesting and open source. Yeah, we can do stuff on hearing as well. So we covered some cochlear implants. We could also do hearing loss. So we actually had some prompts there that we could use. Oops. Yeah, I have some prompts on detection theory as well, which could be interesting. Oh, also remember we were working on a rock curve. So if you can give a brief introduction to the rock curve. I'm not sure if the viewers are familiar with it or not, but we need an introduction anyway. We started an application. It's not working very well at the moment. or is it already? Yeah, it's already deployed. I forgot the name of it. Yeah, if you can look up the name from the XML script provided above. Yeah, just give a general overview and we'll go from there. Yeah, quick responses would be great. If you feel like being funny, just go for it. Yeah, it's called Cardio Rock. That's right. Might be doing more development on that one. There's no search at the moment. It's a bit annoying. But, this is what it is. It is the landing page is divided by sections. So interior rock curve should be in analysis somewhere. Yeah, eventually we'll have a thumbnail image for all these tools. Can't find the rock curve. You can just do your a normal search. It's called Cardio Rock. Right, so it's essentially the game. Yeah, we need to improve it quite a bit. And it will start placing data points on a rock curve, which is your, I forgot what it stands for, response. Yeah, receiver operating characteristic curve. It's such a bad name. I don't know why even bother. But anyhow, yeah, you can see the points are already there. They're just really close to the left of the screen. We have to fix that. Yeah, having all sorts. So we need like a false positive, false negative, true positive, true negative for to start showing something useful on the curve. So currently we have a dead point. That should be another a false positive. So it's going up. Yeah, if I do this, it should go down. So that's not good. Why the colors are opposite? That's good. And if I ignore it, it should be green. If I click on it, it should be what? Doesn't make sense, does it? Yeah, I have to look into the code. Yeah, if you keep making mistakes, the area, essentially this area under the rock curve will keep going down. If I click on it, it should go back up. Yeah. Have to test it, every single bit of it. Yeah, so if you've seen this game before, we have a similar game on the page. This will be in the ECG section. Yeah, it's this cardio board. Yep, there's the videos of me getting to about like 1,000 points. Vivid. You meant to not click on something that looks like normal ECG and click on something that looks abnormal. So good luck with that. You're playing against a machine that does pretty well. Well, much better than a human, so that's why I'm saying good luck to us all. So in this version of the game, you're essentially doing the same thing, but it will plot the receiver operating characteristic curve for you as you go. So essentially the area under that curve, area under the curve measure how well the model distinguishes, but which in this case the model is you. So it will essentially give you a score of how well you are doing. In that case, we just give you 10 points for every correct response and take 10 points if you respond incorrectly. So if I click on this correct, yeah, you still have the score there. And the points that I should have clicked on that. And it's going down. It's kind of hard to tell what it's doing. It's also hard to tell which was the last point. So maybe we can get the... Hey, can you explain what's on the front panel? Hey, don't mind the details. If you feel like being funny, go for it. But stay on topic. Yeah, I might pop in a bunch of images there. Just so it knows. Yeah, so at the point we are not performing well, so we expect this area under the curve to go down. So if we're not performing, we expect the area under the curve to go down under the curve. We will share the code with you in a sec. We would like to improve it. There's some, it's unclear what is it doing at the moment, where the most recent point is. Any suggestions for that? Perhaps we could have it like blinking on the screen or something after its place, so we know that was the last one. Yeah, that actually makes sense. So it was green is essentially an incorrect response, which is a bit counterintuitive. It should have been the other way around. So say if I don't press on this, which I should have. Yeah, now it's also hard to see which data point is which. Also, if you can address another issue is that in the beginning, when we don't have any measurements, how can we go about it? It will start placing data points on the edge of the chart, and it's hard to see them. Also, we seem to be doing a linear approximation to the rock curve, which is not ideal. Can you recommend something else? Hey, just make sure continuous sentences, full paragraphs, no code at this stage. We will be doing coding later. We actually have another robot doing the coding for us. So maybe you could just provide instructions for GitHub Copilot to actually do the coding itself.
It sounds like you've got a lively and challenging game with Cardio Rock, but you're dealing with a few usability and logic issues that could make the experience smoother and more intuitive for players. Let's address each of the concerns step by step, with some suggestions on how to make things clearer and more effective. 1. Identifying the most recent point on the Rossi curve. To solve the problem of not knowing which point on the rock curve is the most recent, it makes sense to visually distinguish the latest point from the rest. Blinking is a great idea since it draws attention without adding clutter. But let's refine it a bit more. You could make the latest point blink with a soft fade in and fade out effect to make it less jarring. Alternatively, consider adding a temporary glow or enlarging the point slightly when it's first plotted. This way, players instantly recognize which data point corresponds to their most recent action. You might also consider changing the color or adding a small, subtle animation, such as a pop effect when the point appears. This would add a dynamic feel to the interaction, enhancing the player's understanding of their progress. Hop 2. Correcting the color logic. The current use of colors, where green is an incorrect response, is indeed counterintuitive because green is usually associated with correctness or success. It would be better to swap the colors. Make green represent a correct detection, true positive, and red for an incorrect detection, false positive. This simple change aligns with common visual conventions and instantly makes the game more intuitive. Furthermore, you could add a tooltip or a small label that appears when hovering over each point, providing feedback on what each point represents, e.g., correct detection or misdetection. Initial points visibility on the rock curve. At the beginning, when there are few measurements, points plotted on the edge of the chart are hard to see. To fix this, you could add a small buffer or margin around the edges of the rock plot, so the initial points don't appear too close to the boundaries. Another idea is to introduce a short animation effect where points are plotted gradually moving toward their correct positions, starting from a central point or from the middle of the graph. This gives them some separation from the edges and helps the user find the plotted data right from the start. Hazard 4. Improving the rock-sea curve approximation. Using a simple linear approximation for the rock's curve isn't ideal because it oversimplifies the model's performance, especially when dealing with varying thresholds. Instead of a linear connection, consider using a piecewise linear interpolation or even a spline curve to better represent the true nature of the rock space. A more sophisticated approach would involve plotting a convex hull around the points to maintain a valid Rossi curve representation, which only curves upward or remains flat. Additionally, it might be worth exploring the use of smooth curve fitting techniques, like cubic splines or monotonic interpolation, to generate a more realistic Rock-C curve. This would accurately capture the transitions between the decision thresholds and avoid misleading representations of the model's performance. The goal is to have a curve that realistically shows the trade-offs between sensitivity and specificity, giving players a more accurate understanding of how well they are doing. 5. Instructions for GitHub Copilot. When you're ready for coding, you can give GitHub Copilot specific prompts to implement these changes. For blinking or visual cues on the latest point, create a function that makes the most recent point on the Rock-C curve blink with a soft fade effect for 3 seconds after it is plotted. To swap the color logic, adjust the color coding so that correct responses are displayed in green and incorrect ones in red, and add hover tooltips explaining each point. To handle initial points better, add a margin buffer around the edges of the rock plot to ensure points are not placed too close to the boundaries, and implement a short animation moving points from the center to their correct positions. For rock curve approximation improvements, replace the linear approximation with a piecewise linear interpolation, or use cubic splines to generate a smoother and more accurate rock curve representation. These instructions should guide your other robot to make the necessary code adjustments effectively.
Okay, so the rock curve, the data points on the curve do make sense. So it's going up the specificity and sensitivity as you do more and more correct responses. The linear approximation obviously doesn't work very well. Well, pun intended, it's like not sensitive enough to the changes. So might use a different approximation. So I'm trying to think if the colors make sense or not. So essentially I think currently it's one color for when pressing, when clicking on the waveform, and another color when not clicking on the waveform, which is one way to go, but probably even better would be having red for wrong and green for correct. So should I be sharing the code with you, or is it better for you to provide instructions for another robot? Yes, we want to make sure red is indicating incorrect labels and green indicating correct labeling. Now, yes, we would like to try different interpolation. Also, we need to make sure the labels to the graph are visible. What do you think?
You don't need to share the code with me directly. It's more effective if I provide instructions that you can then use with another robot, like GitHub Copilot, to handle the coding tasks. That way, you maintain full control over the code, and I can guide you through the changes to improve your application. Here's a refined set of instructions to accomplish the updates you want. 1. Color logic adjustment. Ensure that red represents incorrect labeling and green indicates correct labeling. This change will help align with common visual conventions and user expectations. Instruction for Copilot. Update the plot function to change the color of points to red for incorrect responses and green for correct responses. Make sure the colors are consistent across all visual elements. Different interpolation techniques. To explore different interpolation methods, consider using a more sophisticated technique, such as a piecewise linear interpolation or cubic splines, instead of a simple linear approximation. These methods will better capture the nonlinear nature of the rock curve. Instruction for Copilot. Replace the linear interpolation currently used for the rock curve with a piecewise linear interpolation or cubic spline method. The goal is to create a smooth curve that accurately represents the trade-off between true positive rates and false positive rates. 3. Label visibility enhancement. Make sure that all labels on the graph, such as axis titles and point labels, are clearly visible. You can achieve this by adjusting the font size, contrast, or positioning. Instruction for Copilot. Add axis labels, true positive rate and false positive rate, with increased font size and high contrast colors. Ensure that the labels are not obscured by the plotted points or other graphical elements. 4. Highlighting the most recent point. Make the most recent point on the ROS curve easily identifiable. A blinking effect or an enlarged marker could work well. Instruction for Copilot. Implement a feature to make the most recent point on the rock curve blink with a soft fade in and fade out effect for 3 seconds after it is plotted. Alternatively, increase the marker size temporarily to draw attention. Number 5. Handling initial points. Adjust the placement of initial points on the rock curve to ensure they are visible and not too close to the graph's edges. A short animation or buffered margins can help here. Instruction for Copilot. Add a buffer margin around the edges of the rocks plot to prevent initial points from being placed too close to the boundaries. Consider adding a short animation where points move from a central position to their correct location on the graph. Summary. By using these instructions, you can direct Copilot or any other code assist tool to make your game more intuitive, visually clear, and functionally robust. Let me know if you want more details or suggestions.
Okay, yeah, so it is a better way to do it. Is to use GitHub Copilot. So we started with the first prompt, adjusting the colors. So do we just integrate the whole thing? Yeah, we can apply. Don't know if that works at all. Well, we will see in a second. To restart it, do we? Okay, it doesn't work at all. Well, because we had like almost 200 lines of code and now it's only a bugger all. Draw rock. Not actually changing anything there, do we? So say this function. Yeah, nothing have changed, I don't know why. And now we have draw rock. Do we need update rock? So this should be incorrect, should be red. There, something's wrong. It's the opposite. Okay, I don't know if it's better or not. But those two errors are okay. Yeah, that's fine. So where is the interpolation happening? We just pop it anywhere. A workspace, command, replace the linear interpolation currently used in the ROP curve with piecewise linear interpolation or cubic. So we're using D3 library for plotting a D3.js. Should be something JS. What are we using anymore? Okay, are we using JS or are we using something else? Are we using D3 JS? No, we don't want. What are we using at the moment? I mean, it's working already. Why change? What are we currently using to plot? HTML5, a Canvas API. Okay, it works. So replace. So same operator, we're using a workspace operator. Here, replace the linear interpolation. It's going for D3 library. Should we actually use it or? So it's changing the draw rock. Alright, so we're using math, just the standard maths JavaScript. But yeah, it looks like we'll have to use something more complicated. This won't work because we're not calling the library. To make sure we have this script. Yeah, D3 is not defined. It is script in the HTML. It should go in the beginning somewhere. Should get 10 points back. Ooh, get a lot of. Can click on it, should go to 30 points. And where's the line? Where is the interpolation line? Yeah, might need to bring the big guns GPT-4 for developing the code. Yeah, don't see the lines being plotted. This should be incorrect. Response should give a red, but it didn't. Give a green one. Should give green, gave a red one. What? Okay, what do we do? I wonder if ChatGPT will also suggest the D3 library instead of just the basic maths one. Okay, so yeah, not having much luck with GitHub Copilot. We are not having much luck with GitHub Copilot. I'll be sharing the code with you next. And yeah, tell me what you think. I'm not sure this structure is correct. In the rhythm scan, hey, we have an info text tree structure. So this should generate the whole structure for the file. So we'll just stop the Flask application for a sec. Generate the structure. Okay, so we we have this file and folder structure for this project. Can you just comment briefly? If you want to be funny, we are losing viewers. Just yeah, you can address the viewers directly if you like.
All right, viewers. Let's take a quick tour of the project structure, where your next great biomedical game, Cardio Rock, is coming to life. Imagine this like a backstage pass to your favorite band, but instead of guitars and drums, we have Python scripts, HTML templates, and some mysterious files that are probably up to no good. Project structure breakdown. App.py. This is your superstar, the lead singer of the band. It's the main script where the magic begins, and your Flask app gets everything rolling. Think of it as the frontman who keeps the crowd hyped. This is like the roadie closet. It stores temporary stuff that nobody really sees, but without it, the show wouldn't go on as smoothly. The band's set list. All the configurations and secrets to keep your app tuned correctly. There's another instance config.py too, just for those special backstage VIP settings. A cryptic file. Maybe it's got your deepest secrets, or maybe just some notes. It's like the band's secret notebook. Logs error.log, the blooper reel. Every mistake, every embarrassing slip-up, captured for posterity. My app, the unseen tech crew. It ensures your app is served correctly to the web, just like the guy adjusting the lights and sound. Requirements, grocery list for your Python packages. Whatever your app is hungry for, it's listed here. Static Slack. This is the visual effects team. CSSstyles.cease, the fashion designer, making sure your app looks good on stage. JS/main.js. These two are like the pyrotechnics and stage effects, adding dynamic elements and making sure things move with a bang. Fonts/ and images, props and decorations that make everything pop. Templates index.html, the show floor itself. This is the actual web page where all the performance takes place, with your audience sitting right in front. Test/test waveform generation, PI, the soundcheck team, running tests to make sure everything sounds and looks good before you hit the stage, because nothing's worse than a drum solo gone wrong. So, to our viewers, stick around. We're about to dive deep into the nitty-gritty of making Cardio Rock even cooler. Expect less tech jargon, more rock and roll, and maybe a bit of Python humor to keep you engaged. All right, now that we've had our backstage tour, what's next? Share a specific file or code snippet, and we'll start improving this show.
Yeah, so trying to improve this. Yeah, it's displaying the last so the last data point being larger and then going smaller for the next waveform. It's a really nice touch. Thank you very much. Yeah, adding labels to the chat would be really nice. So we are modifying the JavaScript as per your suggestions. The draw axis label is not currently used. So we changing the draw rock reference line. Yeah, adding some margins. So that should be okay in theory. Okay, so instead of directly connecting the points in a straight line, use a cubic spline. Okay, that bit we are not sure about. Also, we need to make sure the colors are correct. So we want green for correct responses and red data points for incorrect labeling. So this is what I have at the moment for the JavaScript. Any suggestions? Welcome. Okay, how did we get away without using the free library so far? A quick funny response will be great so we don't lose any audience.
Well, it seems like we've been throwing curveballs without a pitcher's glove, just winging it with pure JavaScript swagger and a dash of overconfidence. Imagine we've been building a smooth jazz band without realizing there's this cool saxophone called D3 sitting right there. Instead, we've been humming all the notes ourselves just to keep things interesting. But hey, sometimes you've got to fake it till you make it. Or in our case, just draw straight lines until the curves catch up.
Okay, really, you are really selling it, aren't you? So, okay, we will be using D3 as per your suggestion. So we adding the script into the HTML. And modifying the draw function to use D3 lines, but not JavaScript. A draw rock. We're currently ending at line 153, and with this one we expect it to be longer. Yeah, 162. And what else do yeah, so the correct color, the color coding logic looks correct now. Okay, we'll be testing it in a sec. Improving the access label. Okay, so in draw rock again, we're adding the draw labels at the bottom. So we expect 162 line to expand. Okay, it's still 162. Let's see. Um, why I cannot refresh the page? Control F5, what? Haven't experienced this before. What's up? Rock. Yeah, I can hear my fans there, and it's also the server, so it's not great. It's not the eye tracking business, that's not taking many resources, but the code. Yeah, something happened to that rock curve a game thing. We have to, well, just start it again. It's a Flask application, so I have to run this Python backend. Okay, we have false positive rate, true positive rate, and that doesn't fit the screen. That's not cool. Okay, that's not cool at all. Need to fix this. What's up with the lines? Getting any errors?
Haha, looks like we're in a bit of a jam session where the saxophone D3 is still tuning up, and the audience is wondering why the drummer, your rock curve, is playing off beat. Let's figure out what's happening here with your rock curve and the axis labels. Troubleshooting the rock curve and labels issue. 1. D3 integration check. It looks like you've added the D3 script correctly to your HTML, but something's causing the page to get stuck or not refresh properly. This could happen if the D3 code is causing an infinite loop or a heavy computation that the browser struggles with. 2. Axis labels overlapping or not fitting. The axis labels seem cramped or don't fit well on the screen. This might be due to hard-coded positions or not dynamically adjusting to the canvas size. Here's how to smooth out the kinks. A. Ensure proper integration of D3.js. Make sure you've included the D3 script correctly in your head, HTML, script circles at d3js.org, d3.v7.min script. B. Update the drawRock function for smooth curves and dynamic axis labels. 1. Fixing the rock curve drawing. Update the drawRock function to use D3's line function more effectively. Ensure that the path created by D3 does not cause any performance issues by wrapping it in a single Path2D object. 2. Dynamically position axis labels. Make sure the axis labels adjust dynamically based on the canvas size. Use canvas.width and canvas.height properties to determine their positions. Updated drawRock function. Here is an enhanced version of your drawRock function that uses D3 for smoother curve interpolation and fixes label positioning. JavaScript function drawRock. Clear the rock canvas.
Yeah, I'm having a few problems. Okay, let's go back to the drawing board for the sec. First of all, the lines, instead of just connecting the data points, we want them to be an interpolation of the rock curve. So later, or even right now, we can calculate the area under the rock curve. So if we can adjust that, it will be nice. I mean, is that line connecting the dots even useful? No, it will be just going all over the shop. So just get rid of it. All over the shop. Okay, now the position of the labels needs to be fixed. And yeah, and we'll just go from there. We will just go from there. Is it still in a funny mode? In a stand-up comedian mode? Yes, it is.
All right, back to the drawing board. Let's get rid of those janky lines connecting the dots like a toddler on a sugar high, and instead focus on smoothing out the rock C-curve with a proper interpolation. We also need to tidy up those axis labels so they're not doing gymnastics across the screen. 1. Smoothing the rock curve with interpolation. Instead of directly connecting the raw C points with straight lines, we can use a cubic spline interpolation, which will provide a smooth curve through your data points. This is crucial if you later want to calculate the area under the curve, AUC, accurately. Updating the rock curve drawing. Using d3.js, we will employ the curve basis or curve catmull-rom interpolation method, which is designed to create smooth curves. Modify your drawRock function like this. JavaScript function drawRock, clear the rocks.
What I currently have for the styling of the page. We just want to do specific styling for this page. Don't worry about the website logo and the drop down menu. Just focus on the items for this specific application. Yeah, we also had one of the functions is not being called. Okay, it's not moving across the false positive rate at the moment. Yeah, I have the game canvas. We have the score display, noise slider container. Yeah, we don't need to do anything with the overview. And I suspect it's not actually being called because we're not calling the correct, meant to be static. A CSS folder. Oops. What just happened? A relative path. Want to change to this file. What? Just call this file here. No, just call the file. Do I need to tell you how to do it or? Okay, that's what I did, didn't I? Obviously not. Okay, this is not fun. Let's do the full. The full path. Well, that will work only when deployed, is it? Well, will work now because it's already deployed. Okay, whatever works. Just moving on. Moving on. I don't know why the labels are inside. Okay, a couple of things. First, the labels of the rock curve are inside the chart. That's not great. Can we fix that? Also make sure that the y-axis label actually fits. We can make that chart a bit bigger. So it still fits the screen horizontally, but make it a bit taller on the vertical scale. The adjusting noise level does work. Yes, it does. Now can we also make sure that the points that are sitting on the axis, plural, are actually visible somehow? Because currently we only see half of them, or maybe that's okay. I don't know. What do you think? And yeah, keep engaging the viewers somehow. We need more views, subscribers, and the like. If you feel like being funny, go for it. But yeah, mainly focusing on fixing this web application. And we still have connecting lines between the data points, which I thought we are getting rid of. But they're obviously there. And then we also need to make sure we're actually interpolating the rock curve. So later we can calculate the area under the curve. Any ideas are more than welcome.
All right, let's dive back into it and make this cardio rock game shine like a YouTuber's thumbnail on a mission to hit that million subscriber mark. Let's clean up the labels, fix the interpolation, and make sure our rock points are visible and engaging for all those data-loving eyes out there. 1. Fixing the axis labels positioning. We want the labels to be positioned outside the rock chart area so they don't interfere with the curve and points. Also, let's make the chart a bit taller while keeping it horizontally aligned with the rest of the page. Update canvas size and label position. Adjust the canvas height and make the labels dynamically fit outside the chart. CSS had rock curve-canvas, background color F5, 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 border 2px solid, box shadow 0, 4px, 8px, RGBA 0, 0.1, margin bottom 20px, width 100%. Ensure full width, height 300px. Increase height for better visibility. Update the JavaScript function for axis labels to move them outside the chart area. JavaScript function draw axis labels. rockcctx.font equals 16px Arial. rockctx fill style equals 33333333. Dark color for text. Position x-axis label dynamically below the canvas. Const x label x equals rockcanvas.width 2 minus 60. Const x label y rockcanvas.height dice 15. Adjusted to fit outside the canvas rockctx.fill text false positive rate x label y 25. Slash position label below. Position y-axis label dynamically on the left side outside the canvas rockctx.save. Const y label x equal 50. Position to the left of the canvas. Const y label y equals rockcanvas.height 2. rockctx translate y label x.
Hey, can you actually provide the text, full sentences, funny ones first, and then we do a code in a separate response. And now we also might need to adjust HTML to make sure the ID names are correct. But again, do the text first and then we regenerate the code later on.
Absolutely. Let's sprinkle some humor over the text first to keep our audience entertained while making sure the messaging is crystal clear and engaging. Here's a fun yet informative rewrite of your current content that keeps the essence but adds a bit of flair. Revised and humorous text for Cardio Rock webpage. Cardio Rock, the game where your heart and brain race. Score, or maybe a little higher if you're good at this. Overview. Welcome to Cardio Rock, the game that's more than just a test of reflexes. It's your chance to prove you can handle the pressure, both on screen and in the operating room.
No, don't worry about it. Don't worry about the text for now. We just need to fix the IDs in the HTML. Okay, let's give you a bit more focus. Yeah, we need to make sure this will work with the JavaScript that we have. Not the waveform JavaScript, just the main JavaScript file. But can you provide the text of what are we gonna do first in an engaging manner, and then we generate the code in the next response?
All right, folks, let's buckle up and dive into the first steps to get this cardio rock game running smoother than a Swiss watch on a greased slide. What are we going to do? First things first, we need to make sure all the gears in this JavaScript engine are turning in perfect harmony with our HTML. That means aligning the IDs of our elements, like an orchestra tuning up for a performance. Because right now, our script is playing the right notes, but the instruments aren't quite in sync. No one wants to hear a concert where the drummer's offbeat, right? Step 1. Check and update the IDs. We have to make sure every HTML element is properly referenced by JavaScript. This means 1. Double checking the IDs. We'll make sure every ID in the HTML, game canvas, rock curve canvas, human score, and noise slider, matches exactly with what our JavaScript is trying to grab. If even one of these IDs is off by a pixel, okay, by a single character, the script won't work as expected. Number 2. Adjusting any misalignments. If there's a misalignment, we'll adjust the HTML accordingly. Sometimes it's like fixing a flat tire. Other times it's like swapping an entire engine. Luckily, today we're just tightening some bolts. 3. Making the interaction smooth. Our JavaScript will interact with the canvas elements for drawing waveforms and plotting the rock curve. To do this efficiently, we need to ensure every ID matches, every element exists where it's supposed to, and everything is wired up correctly. Step 2. Optimize the HTML structure for better interactivity. The div for the score display, the canvas elements, and the control inputs should be positioned properly to keep the layout clean and the gameplay engaging. We'll also ensure that the noise slider is easy to control. The score, human score, updates dynamically, providing real-time feedback. The rock curve canvas, has enough space to breathe, and the labels are properly aligned so it doesn't look like they're auditioning for a modern art exhibit. Step 3. Make it fun. Make it flow. Our game should feel like a smooth, enjoyable ride where the interface is intuitive and responsive. Imagine driving a sports car. You want quick feedback, smooth handling, and a display that tells you exactly what's happening in real time. That's what we aim to achieve by ensuring every HTML element and JavaScript function is synced perfectly. Why is this important? Think of this as the behind-the-scenes choreography for our game's big dance number. If the IDs are off, the game doesn't work, and nobody wants a performance where the lead dancer trips over their own feet. This is about precision and making sure everything is set up so that the JavaScript can do its job without stumbling. So, let's get those IDs checked and aligned in our HTML, making sure they are ready to work hand in hand with our JavaScript. Once we've got that sorted, we'll dive into the next part, polishing the code so this game is as sleek as a James Bond getaway. Stay tuned for the code in the next response.
Okay, can we update the JavaScript code? And also the CSS to make sure the labels are on the outside of the chart, not inside the chart, to make sure we don't actually have lines connecting the data points, and making sure that we do have the interpolation of the data points. The interpolation line should be going all the way from 0, 0 all the way to 1, 1. How does that sound? Can you also give a fun summary to the code before we're losing viewers?
All right, folks, gather round for a fun dive into the heart of the cardio rock code. This isn't just some boring old script, it's the secret sauce that turns your clicks into high stakes, data crunching drama. Picture this: you're a biomedical detective in a game that tests your ability to spot sneaky abnormalities in an ECG waveform. The stakes are high. Each correct click brings you closer to the coveted top left corner of the rock C curve, a mystical land where sensitivity and specificity are the names of the game. But beware, one misstep, one false click, and your curve drifts off into mediocrity, much like a bad karaoke performance. What's under the hood? 1. Dynamic canvas resizing. The game adapts. No matter how big or small your screen is, the ECG waveform and rock curve will flex to fit it perfectly. Think of it like spandex, but for medical data. 2. Noise control slider. Feeling brave? Crank up the noise to see if you can still spot those tricky abnormalities, or dial it down if you're feeling like a cautious clinician today. 3. Interactive gameplay. The waveform dances across the screen, daring you to click. Hit the target, you score big. Miss? Well, your curve starts taking a leisurely detour away from that sweet, sweet top left corner. 4. Real-time rock curve. No need to wait for a professor to grade your performance. Your rock C curve is updated in real time. Green dots mean you're a genius. Red dots? Well, maybe it's time to review those textbooks. 5. Smooth interpolation magic. With the power of D3JS, we make your performance look smoother than a well-executed moonwalk. No jagged lines here, just a silky curve that shows every decision you've made, for better or worse. 6. Labels outside the chart. Because nobody likes a cramped chart, right? Our labels are placed neatly outside, leaving all that precious canvas space for your diagnostic prowess to shine. The takeaway: by blending serious data science with game-like elements, Cardio Rock makes you feel like you're piloting a spaceship through a galaxy of biomedical signals. You're not just playing, you're sharpening skills that could one day save a life. So keep those eyes sharp, hands steady, and let your rock curve soar. Bonus round. Want to see your name on the leaderboard? Play again, tweak your strategy, and maybe, just maybe, you'll get your raw C curve to hit that perfect diagonal line. Stay tuned, keep clicking, and may your true positive rate always be high.
Okay, can you explain these two images? We will need to go back to the code at some stage and figure out the colors. They seem incorrect. We also still have the lines connecting the data points. I thought we said we are getting rid of them. We need an approximation line connecting 0, 0 point to 1 point, and approximating all the dot points on the rock curve as and it should change as more points are being added. So can you just generate the response in text of how we're gonna go about it, and we'll update the code later on.
Let's dive into what we're seeing in these two images and map out how we'll tackle the issues we're facing. What's happening in the images? 1. First image. Score 20. The rock curve plot at the bottom is starting to take shape, but we still see those pesky connecting lines between the individual data points, creating a zigzag pattern that makes the curve look more like a roller coaster ride than a smooth, meaningful diagnostic tool. The points are plotted in a mix of red and green, but the color logic seems off. We should only see green points when a correct decision is made, e.g., correctly identifying an abnormal waveform, and red points when there's a mistake, e.g., false positive or false negative. The overall shape of the points suggests we're getting some data through, but we need to better visualize it with a clean, smooth interpolation. 2. Second image, 170. The game is in action, and the score is dynamically updating as the player clicks, indicating that the scoring mechanism is working. However, the issues with the rock curve persist. Lines are still connecting the data points, and the color logic still needs fixing. We also lack the desired approximation line that connects the starting point, 0, 0, to the ending point, 1, 1, which would help us better interpret how well the player is performing over time. The plan to fix these issues. 1. Remove the unwanted connecting lines. We need to modify the code to prevent it from drawing lines directly between the individual rock points. The d3.line function in our code should be focused on smooth interpolation, not simply connecting the dots. We will ensure it draws a smooth curve through the points without sharp, jagged lines. 2. Correct the color logic. Update the logic that determines the color of each point. Make sure that green points represent correct classifications, true positives, and correct rejections. Red points represent incorrect classifications, false positives, and misses. We can do this by adjusting the conditions within the loop that plots the points, ensuring the color reflects the accuracy of each decision. 3. Add an approximation line from 0, 0 to 1, 1. Implement a line that runs diagonally from 0, 0 to 1, deal 1. This line acts as a reference or a baseline that shows the performance of a random classifier. Ideally, our rock curve should bend towards the upper left corner, above this diagonal line, to indicate good performance. We will use the D3 library to draw this line separately from the rock curve points. This line should not change. It's a static reference to help visualize the overall performance. 4. Implement smooth interpolation for the rock C curve. Use D3's interpolation methods, d3.curveBasis or d3.curveMonotoneX, to create a smooth curve that passes through or near the rock points. This curve should give a better visual approximation of the performance trend over time. The curve will dynamically update as more points are added, providing a real-time, smooth visualization of the rock data. 5. Calculate the area under the curve, AUC. Once we have the smooth ROC curve, we can calculate the area under the curve, AUC, to provide a numerical value representing the player's performance. A higher AUC value indicates better performance, while an AUC close to 0.5 indicates random guessing. This will be a future step, but it's worth planning for now as it ties into visualizing the curve correctly. Next steps. 1. Remove the lines connecting the individual points. 2. Correct the color coding logic for the points. 3. Add the static diagonal line from 0, 0 to 1, 1. 4. Use D3JS for smooth interpolation of the rock curve. 5. Prepare to calculate the AUC once the curve visualization is finalized. By making these changes, we'll ensure the raw C curve is more visually accurate and meaningful, providing the right feedback to the player in real time.
Okay, we're a bit slow today. Let's go step by step. Why the labels for the rock curve chart are not visible? Can we also make sure they are outside the axis of the chart? Yeah, not sure why that didn't work. The labels are still on the inside of the chart, but let's just move on, checking the color of each data point. Can we make sure when the response is correct, the data point is green, and when the response is incorrect, the data point is red? So this one should be green. Yeah, this is wrong. Stop generating is not a good sign. When it's stuck like this, it's probably an error on the server somewhere. Yes, we're actually playing. The interpolation should keep adjusting. It's only interpolating between the last two data points, whereas it should be interpolating the whole thing. Yeah, that should have been green. It's always green when I'm not clicking on this. What? So red should be green. Yeah, red should be green. Ah, okay. Don't know how to fix it. There's a couple of things going on. Couple of things going on. And we have to fix all of it. There are a couple of things going on. We need to dive into the details because I don't like the way it is at the moment. So first, the interpolation. It shouldn't be just happening between the last 2 points. It should be happening between all the data points on the chart. So we should just have any type of interpolation between 0, 0 and 1, 1, including taking into account all the data points in between on the chart. And it should keep updating as more data points are added. Now the colors, we need to make sure the colors are okay. Currently there's something weird going on. We need to just figure out what is it. We might need to export to print out the point correct value. Because currently something is funny going on. We need to make sure the calculations for the true positive rate and true negative rate, false positive rate and true positive rate are correct. So we don't mind going to the diving deep into the details of it.
It looks like we need to make some more detailed adjustments to the rock-C curve generation and point coloring logic to ensure that everything is working correctly, including the interpolation and calculations for the true positive rate, TPR, and false positive rate, FPR. Let's address each of your concerns step by step. 1. Ensure proper interpolation of all data points on the rock curve. To achieve a smooth interpolation that takes into account all the data points from 0, 0 to 1, 1, we need to make sure that the interpolation is not just between the last 2 points, but includes all points along the rock curve. The key is to use D3's D3.curve basis or D3.curve monotone X for smooth interpolation, while ensuring that the line is calculated using all data points from the start, 0, 0 to the end, 1, 1. Updated code for smooth interpolation. We'll adjust the drawing function to include a path that starts at 0, 0 and ends at 1, 1, while interpolating smoothly between all intermediate data points.
Yeah, I would like to simplify the interpolation. It should be just an exponential, always going through 0, 0 and 1, 1 points on the chart. and it should be recalculated every time another point is added onto the chart. Also, the colors are still wrong. The data point is moving in the correct direction, but the color of it is not correct. The calculation is incorrect. So when it is, we need to make sure that when the user clicks on abnormal waveform, it is correct true positive. When the user clicks on a normal waveform, it's false positive, and so on and so forth. Can we get that right? That's absolutely critical.
To simplify the interpolation and ensure it uses an exponential curve that passes through 0, 0 and 1, 1, we can adjust the way we handle the Rossock curve's plotting logic. Additionally, we need to fix the logic for coloring data points to ensure they accurately reflect the correctness of the user's responses. 1. Simplifying the interpolation to an exponential curve. To create an exponential interpolation that always passes through 0, 0 and 1, 1, we'll define a simple exponential function that fits the Rossi points. The idea is to generate a curve that starts at 0, 0 and ends at 1, 1, while adjusting the intermediate points dynamically based on the data. Texture update for exponential interpolation. Let's assume we want an exponential function that passes through all rock points and always through 0, 0 and 1, 1. Here, we will use an exponential function y equals ax squared b to plot the line. Since we want the curve to go through 0, 0 and 1, 1, we can normalize the rock points and adjust the base a and exponent b to make it fit between these two. Updated drawRockC function. We will update the drawRock function to recalculate the exponential curve every time a new point is added. JavaScript function drawRock, rockctx.clearRect, 0, rockcanvas.width, rockcanvas.height, / clear the ROC canvas drawRock reference line, / draw the reference diagonal line from 0, 0 to 1, 1. Include start and end point 0 and 1, 1. Const all points. Include const all f0, f.
Some problem. It looks better in a sense. Yeah, it should be reversed. But then there's something wrong with the calculation. It seemed to be moving in the right direction. Yeah, the score is moving into the right direction. Okay, we're having some problem. So this is much better. The exponential curve is good. Even though there probably could be a better way of doing this. Any suggestions are welcome. Now it should be reversed, so it should be above the midline as the image attached. Now there is still something wrong with the calculation. The response on the score is behaving correctly, but the response type is wrong. It was just delayed by one or something. I think it actually might be delayed by one. We need to test that. Yeah, we might need more troubleshooting. But the score is behaving correctly. Also, the data point can be added at the same time as we click on the waveform. This is the same time as when the score is being updated. So we don't have to wait for the waveform to scroll through before placing another data point on the chart. We oh, okay. Wasn't listening. Yeah, we need to fix this logic. The logic is flawed. We might do it next time. I'll see you in a bit. Don't forget to check out the website.